Hi everyone, in this segment we are going to be discussing asymmetric centers. Asymmetric centers are also known as chiral carbons or chiral centers. These are carbons that are sp3 and they are bonded to 4 distinct atoms or groups. Sometimes we call them stereogenic centers, and we use the classifications of R and S to distinguish asymmetric centers. Okay, so let's visualize a couple. This chiral carbon here is bonded to 4 distinct atoms or groups. It is a chiral carbon. This carbon on the right side, notice how it's bonded to 3 hydrogens. So it's not bonded to 4 distinct atoms or groups. That is not an asymmetric center. Our asymmetric centers are bonded to 4 distinct atoms or groups. This is an asymmetric center. It's bonded to an amino group, a hydroxyl group, a hydrogen, and this ketone functional group. Okay? So your visual reference point is this, and you're saying, what groups are coming off of that one point? Here there are 4 different groups, therefore it is an asymmetric center. Here is an asymmetric center. We have a chlorine, a hydrogen, an isopropyl, and a benzene ring, asymmetric center. This carbon here is not an asymmetric center because it has 2 of the same groups coming off, not an asymmetric center. Okay? Very important that we think about that. Now, in the next molecule, we have an asymmetric center, 4 distinct groups. Here we have 2 asymmetric centers, this carbon and this carbon. We have an OH, there would be a hydrogen off of that carbon, and while we do have carbon and carbon, notice how the downstream attachments are different. That means that this attachment point and this attachment point are different groups. Okay, there is an asymmetry about that carbon. It is an asymmetric center. We have a chiral carbon. This is also a chiral carbon. We have this ester group. We have a hydrogen here, which would be a solid wedge. And then these carbons will ultimately differ in their downstream attachments, and therefore we have an asymmetric center. So you might have to scan a molecule to figure out the presence of asymmetric centers, and it might not always be readily, visually something that you can pick up. Here there are 1, 2, 3, 4 asymmetric centers. Your eye should be drawn to these solid and these dash wedge groups, but don't always rely on seeing solid and dash wedges, because it might be the case that your professor puts groups in the plane of the page with no perspective and is making you rely on your ability to distinguish those 4 groups as being different without the stereochemistry. Okay? But again, asymmetric centers are carbons that are bonded to 4 distinct atoms or groups. They have to be sp3 hybridized, and we will ultimately learn how to classify them as R and S.